Welcome, sir. Mr. Raghunath graduated from RVC in the year 1972 and got his ME Structures degree from UVCE in 1976. Mr. Raghunath started his career under the guidance of Shri R. Sundaram in 1973 and has been associated with him ever since. He worked in the Middle East for 16 years and later he returned to India and involved with many development projects to his credit, and he is a person who cares for common man and a lot of effort in this direction from him. Please welcome Shri Raghunath. Thank you, sir.
Dear friends, delegates, chief organizers and all other dignitaries, it's indeed a pleasure for me to be here in the middle of all of you in this magnificently It's a pleasure for me to be in the middle of all of you in this magnificently organized symposium. Okay, I'm very thankful to all of you. But my special thanks is to my mentor, guru and well-wisher, Mr. R. Sundaram, without whose blessings I will be here today in front of you. As far as Redecon is concerned, I think too much is said about it, and by a lot of the real giants in the precasting industry. So I will limit myself to hollow core precasting using ingenious methods, because using imported equipment is suitable for high-rate buildings and bigger projects. But if we want to implement this to meet the needs of the common man, I think we should think about something which is produced ingeniously. And since the time I returned, we have been sincerely trying in that regard. I'm privileged to say that I started my career under Mr. Sundaram, and I am still associated with him in many precast projects. Of course, many of them have not come through, that's a different thing, but we have been seriously working on that. So after I left Sundaram, I went to Middle East, first to Dubai, then Saudi, and then to Germany. But for some time I was settling between Germany and Dubai and Saudi. Now during that period, I was involved in a lot of prestigious projects wherein I converted a lot of cast in situ items into precast components in order to make the time frame as well as the cost-effective methods to be implemented. Some of the projects which I successfully did was, first one was Al-Shaf Cinema, which was an open-air theatre, which was a very, very old thing. I think it was 700 years old at the time. So that was, the walls were all 26 to 28 feet high. So we were asked to redesign that without touching the existing structure. So I designed this structure using prefab methods, and that stood firm against all the wind forces, etc. for a long time. During the last few years, I think some complexes come and that has been demolished. The next one where I got involved was the Fijera Trade Center. You can see the circular restaurant there. It was originally designed as a concrete thing. So the central core had developed some problems in the foundations. So they wanted to reduce the load. So I got it redesigned using precast and prefab methods and cast-related beams, radially located. And even those parapets and those fins were all precast at that time. Then the next thing what I used was water tools. Yes, sir. Okay. Yeah. Right. I can see that. The next one is the Gujarat Central Market, where the water roofs were all originally cast in situ, but we redesigned it to make it into precast items. Even the arches, what you see there, that arched portion of the wall was all precast and fixed into cast in situ. That means it was a composite thing between cast in situ and precast. Then afterwards, I returned to India in the year 1992 with the earnest desire to implement whatever knowledge I acquired into the precast components to be manufactured here. The first project which I ventured was a government project where we used the ribbed wall system. You can see the molds there. Before this, I had already set up a factory in Malu, where we were manufacturing ribbed walls, then hardy block, precast T-beams inverted, then precast door and window frames, then folded plate roof slabs, etc. So using this, in that precast yard, I demonstrated by making molds on with using timber. You can see that. And based on that, I got a good project, but I finally ended up doing only 450 houses, but using all these technologies. You can see that the wall panels are there, ribbed wall panels, 400 of them were stacked in the yard. And then the slab, the trucks, what you see there is folded plate roof system, which was placed inverted, and then the screen was put above. And even now there are no leaks in those buildings. So, yeah, this is the model yard where you can see hardy blocks, hollow core blocks you can see there, and also inverted T-beams. We manufacture a lot of them. I told you we used plenty of them in the governmental projects, and they have worked very well. Now we'll go to these hollow core systems. This is a project actually sponsored by Mr. Sundaram. Of course, it will be supported by Dr. Daniel Pai, who was gracious enough to provide us with the yard where to manufacture these. These are all the hollow core systems, but we have used engineered systems to produce all these walls. And the walls, the roof, everything is hollow core slabs. Suppose you take a first room, what you can see there, type A, B and C is there. So the room size, whatever the width was, to that extent the wall has been made. It's not done in parts. The whole wall is probably 3 meters by 4 meters, 3 meters by 4.5 on these things. And then the whole thing is all bolted together. Now since the walls are all separately done and assembled, we may think it's not structurally safe, but it's not so. Because they are all bolted together, they work like a box. And these hollow core walls have been laid on 600 by 600 by 300 precast foundations, and afterward the apron is being poured around to make it strong. So there is one more point in this. Structurally, even though it is safe, there was a problem which even Mr. Sundaram was envisaging on that, about the insulation values to be accounted for. So I think this, Mr. Prashant will enlighten you on this. And before I get into the insulation values of this, there are some things which I need to explain about this project. First thing is the type of system which we developed for this. As you can see, we first
something which we experimented right on the rooftop of our own house. It's the system which we used to cast these panels, where we didn't want to use any kind of equipment which needs to be borrowed from outside or set up a independent factory for extrusion or anything. We just wanted to do wet casting with a very simple process. So we just used the properties of concrete, like initial setting and the design mix, and also the setting time by using the simple PVC pipes. And later on we of course tried this with steel pipes to get this hollow section. It's a very simple method of producing, although it involves a lot of research work to get it right. Of course the first few experiments will always be there will be some failure, but eventually we now know that it definitely works. Like see, this was the first panel which we cast. Like this was a 600 watt panel. And after that we were absolutely sure, and Mr. Sundaram also inspected it and asked us to go ahead with it. So we went ahead with this project with full scale wall panels and roof panels. As you can see, this was the yard where we cast the panels here, and the erection and assembly happened simultaneously there. As and when we completed the panels required for one type, we went on executing it. What you can see here is both the external walls and the roof is exactly the same type of panel. With the hollow section, we were just able to prove that the structural stability and the insulation required for this value is just enough for comfort level inside. This is just a simple way of how we were able to manufacture and erect this wall panel.
Capable enough to handle the upcoming projects and then
as you can see, all these things were done just in a day, after, of course, everything was secured.
Ask someone to meet me. Send someone. Not a man. So we have a big volume.
Absolutely very minimal equipment here other than this gantry and the mobile crane which we got just for the day of erection. There is absolutely no equipment here. The gantry just moves on rails and then we just stack it and move it across.
We have behind of our, although we sell it, we are not able to do it. Not any
the main intention in this whole project was to demonstrate the precasting quality. So the other details of project are of course left to further refinement and other things for further development.
A number of, I am leading the new technology.
And these are the 3 types which have been executed there, and it's still standing. And there is absolutely no waterproofing on top of it. It's just the hollow core concrete slab, and there has been no leaks till now. Continuing this, when this project was being executed, I happened to go to the Netherlands to do my master's in building technology. And that was when I got associated with my mentor, Mr. Rosekeeper, who just gave a lecture on this flexible mold tray molding. And I had a wonderful time with him while doing this project. I just wanted to continue this effort which we were doing in Bangalore to see how we can develop this system of hollow core to maximize its potential. So here what we came up with, although what we were trying to achieve was smaller scale panels, but in this prototype we tried to devise a panel which had more than 50% void, and the surface of the hollow panel in the inside was not like a big criteria for us, so we just didn't bother about the internal finish of the panel, which is not exposed either to the outside or the inside of the house. So here, this panel is manufactured with ribs, and the structural concept is very simple. We just devise it like an I section, where these 2 layers of this panel behave like flanges, and whatever connects them behave like the web, and thereby we determine the thickness needed to achieve the structural stability in case we are using it as load bearing. Of course, that was my goal also. And then we just devised a very simple method of production, which we are now trying to develop with further method. This was we just used the laboratory facilities with no other equipments other than for the design mix. Here we just use simple wooden mold and you cast concrete with just using an uncompressible material like sand to achieve the hollowness. because it took us a long time to develop this system to make it, to see what was the most economical way of producing it. But in the end, it just worked because the sand could be easily be removed and we could reuse the same process for casting another panel over and over again. And this was the final prototype which I was able to produce there. And as you can see, the finish is absolutely smooth on both sides of the thing, and the joints are also straight. It's just the internal finish is irrelevant, like wherever there's void. But we are able to achieve the purpose for which it was meant. We were able to make it self-assembling, and this was half the scale of prototype for which it was designed, and with this slenderness it was still able to stand. And the same idea we just transferred it onto Bangalore when we came here by eliminating this continuous voids and keeping the edges solid and having hollowness inside, and that still worked without, and this was just done with whatever materials we had on site. It was not even like using the graded concrete. So we were able to achieve the same level of efficiency with this, and the advantage with this is we were also looking at options where this system could be bolted together for assembling, so that because we already have this void inside, and then we could connect them together to assemble on site. And now coming to this, the uses of making this hollow. One is, as we already said, to reduce the weight of concrete to make the dead load lesser. The other one is, of course, the air cavity inside will benefit in the thermal insulation for the residences. And right now I'm working in a facade engineering company in France, where we try to simulate this panel for how much of efficiency we can achieve for thermal comfort. Let's say this panel is 150 thick with 70 mm void inside, and then we compare it with the same panel of 150 thick high strength concrete. With this system, we were able to achieve a temperature which was at least 2 to 3 degrees lesser in the nights, and on average it will be at least 1.5 degrees less over the course of the day for the entire year. And for an unair conditioned space, and in a city like Bangalore, that's a very high level of thermal comfort. And the one thing which I forgot to mention about this panels is we also tried experimenting with higher amounts of fly ash, because there's a lot of fly ash which is being thrown away, and we want to use this for sustainable purposes in India. And theoretically it was proven to be workable, but the prototype we couldn't manage the design, so we're in the process of continuing this research further. The advantage with this system is, since we are using this hollow core for wall, unlike the conventional hollow core which is extruded with dry casting, which doesn't have, you can't provide finish while casting hollow core with extrusion because it has to be dry, and it's you don't get a surface finish which you want. And this one, since it's wet cast, you can already produce it with whatever finish you want, and since you cast it in panels, you can just make it like a architectural solution of how you want with whatever finish you want, and this makes it into, and it opens up newer possibilities of how to get an elevation with just a structural material. At this moment, actually, I would like to take the opportunity to call for, there are a lot of students present here. We just want to see if this can be made into a collaborative research work, because it's in a way it's better that we designers also join hands with all the people involved in the industries to develop a very suitable construction method for Indian context. Now what's happening is the contractors are coming up with their own systems, and we have to go by their system, but sometimes it's already better that we designers also contribute in development of the system, like what Mr. Sundaram has been promoting for so long. And hopefully with the help of Mr. Sundaram we'll achieve our goals very soon. Actually we have a lot more things to discuss other than this hollow core system. Since we have lack of time, we'll just try to make it as brief as possible. I request my father to continue with other things which we are also doing.
Now, other than this structural ones what we have talked just till now, we have got other precasting things which we have been developing for the past 4 or 5 years. Now, what I have basically done after I returned to India is not to demolish old buildings, remodel the old buildings by using prefab and precast methods. Now, that is to restructure the building. Many of them we have done it, but unfortunately, many of the photographs are not with me now to show you. But basically, what we are doing is, we are trying to develop our own lifting technology. For example, we did a job in HBR layout. That was a villa where ground floor was there. We had to put up the first floor. Foundations were weak. So we did prefab method. By prefab method we did it. But how to lift them? Because folded plate roof slabs were all there. Each was weighing about 300 kgs or so. So we developed our own, mini tower cranes to use them to lift those things and put them in place. The other thing what we did was pyramidal roofs, etc. we did. That's okay, fine. Pyramidal roofs, etc. wherein we use the steel structure by using 4 to 4.5 mm plates bent into the shape of channels. That was used. And then over that we used precast slabs, and then finally Bangalore tunnel. This was also lifted by using our own mini cranes, which we developed on our own. So I think the time is over. Is it over? There's still time? Okay, there's no more things. Okay, fine. Right. Oh, that's enough. We also did a temple where the shikara was totally precast and transported from Bangalore to Konigal, somewhere near Konigal. That was in Bislahalli. The problem what we had was the Lord was located at the level of 12 feet 6 inches from the road. This was in fact built originally by Cholas. That's what they told me. So we had difficulty in doing the structure. So shikara what we did was we pre-made it. It was an octagonal pyramid shikara. So we used an ancient old technology wherein we did all the ribs, had rings like that, and then turned it over to make it into an octagon. Otherwise this shuttering system would have been very costly. But finally the whole thing has come out quite well, I should say. And it has been opened last year. We had a tough time during the middle of the operation, but finally it was open. So you can see the erection there. The whole thing, erection was done within half an hour. Only the transportation took time. I think with this I will end my presentation. Thank you all again for giving me the chance to be in front of you.
Thank you, sir. May I now request Shri M. Ranganathan, GC member of ACCE from Coimbatore, to come on stage to present a memento as a mark of our respect and gratitude.
Very soon, I get
Thank you, sir. So, finally, last activity for the day. To take us through paper presentation, may I now request Professor M.U. Ashwat to come on stage and conduct